Hi, welcome in. So I'm going to talk about in this video kind of the extension of the difference of squares and difference of cubes to the general case. So when you have the difference of basically the nth degree, which you see right here, that I'm highlighting. Now, most students will be exposed to the difference of squares and difference of cubes at some point in probably grade 10 or grade 11. Now, the use of the difference of squares or difference of cubes is not very well understood until you kind of get into further grades, in particular into grade 12 if you take advanced functions, and then if you start taking calculus and you start doing kind of derivatives and proving derivatives, in particular, for example, for polynomials or power functions and then radicals. So you use the difference quite a lot. So it's almost like you have to kind of wait for that tool to be utilized later. Okay, so now let's start with the difference of squares first, and then I'll go to the difference of cubes and then the general case. You know, if you like, you can of course fast forward. I'll try to kind of sync the video for you so you can look up which one you're interested in. So for the difference of squares, so let's recall that one. Now, the difference of squares is x squared, minus y squared. Now, it doesn't matter if you call it x or y, or sometimes it's, a squared minus b squared, whatever it might be. Now, the result here is that when you have a difference of squares, we know that we get x minus y, and then this is multiplied by x plus y. Now, of course, I can go ahead and and prove this by just simply this kind of distributing across and expanding it and collecting my like terms, and then I'm going to get my result. So if I would do this, I'm going to get x squared, and this is going to be plus xy minus xy, and then minus y squared, and of course the two middle terms right here will fall off, and then I'm going to get my x squared minus y squared. So that's the famous difference of squares. So that one is nice, and students kind of remember this one. It's not bad. The second one is not as well remembered, and to be honest, if I don't use it for a bit, I also forget it as well. So don't be shocked that you'll forget this one. So the difference of cubes, so x cubed minus y cubed, is equal to, so whenever you have, any difference, so this difference, the first factor, so if you're going to be factoring this out, so this looks like x minus y, so it's always going to be x minus y. That's going to be your first one. And then now we do have this as cubed, so it turns out that this is going to be x squared, and it's actually, all the terms will be now positive because you are taking the difference. Okay, so that's one way that you can remember it. If you have a difference, okay, so the first x minus y, so that minus stays there, but the rest of the terms will become positive. So all of these are positives. And now what happens is, okay, so you'll take x, okay, and this is going to be y, and then this is going to be plus y squared. And you'll see the pattern when I start talking about the nth degree. Okay, so if you understand the nth degree, then the other ones will kind of fall off and you'll understand why they are the way they are. Okay, so this is it. Now, of course, in order to prove this, again, I can play the game of just, multiplying these through. So I can go through the whole thing, so this exercise, and I'll do that in fast forward fashion. Okay, so I'll just expand this out and then multiply through here, and then we'll be back to this to cancel all our items. All right, so there you have it. Now, so with these, you'll notice that you'll have these two terms are going to be canceling off with these two terms, so that's gone, and then these are the only ones that will remain for us, right? So that's all that you're going to have, and then so clearly that shows the difference of cubes is equal to x cubed minus y cubed, and then if you wanted to factor it out, so or factor out the x minus y, that's how you can do that. Okay, so let's take a look and see the nth degree now in terms of the difference. So within here, so if you wanted to do the nth degree, so this would have been, so it's the difference of the nth degree, so this would have been x to the n minus y to the n. And now what does this equal? And then, you know, how would you actually try to remember this? So it turns out it's actually not that bad. Okay, so because it's a difference, so it's always going to be x minus y. So that is, you know, easy enough. You saw that in the difference of squares and then the difference of cubes. Now, the other component, it's always the second, you know, long factor that we're going to be worrying about. So now this big bracket. So I already told you that it's always going to be positive terms. All right, so all the terms are going to be positive. And now, because we do want it to the nth degree, so in order to make that happen, okay, we're going to start with xn to the n minus 1, because we know if we would multiply this through, okay, this is going to give us x to the n. All right, so that's what we're going to have in here. Now, what about all the other terms? So I'm going to shift this down just so that I can show you quite a lot of these terms, okay, in here. So I'm going to shift this down over here. And now they're all going to be positive, right? And now, so here, what we're going to be doing is we're going to be mapping ourselves down on the actual exponent. So this is going to be x. Now, it started with n minus 1. So this is now going to be n minus 2. And it's going to be multiplying by y to the 1. So notice if you would have added, not that you're adding these two because it's not the same base, but if you added, it's always n minus 1. So that would have been your second term in that. And then you're going to say plus, okay, and it's going to be x and then n minus 3. And then this one is going to go up. So you probably are noticing now a pattern that this is going to be x, n minus 4, and then this is y to the 3. And now we continue this. So this goes, you know, this keeps going. And until we eventually, okay, are going to now do it in kind of reverse. So now it's going to be x. So we're just going all the way down. So whatever n is, it's going to be n minus 1, then n minus 2, n minus 3, n minus 4, n minus 5, etc. Until we basically exhaust this entire thing. So here, okay, you know, I would have gotten x to the 3, and now the y's, notice that all the y's have been increasing. So 1, 2, 3, okay, and so on. So this one, okay, is going to be, now you can guess, because when you add them together, they should equal to n minus 1. So this one is going to be n minus 4. And then plus, now this, my x is coming down and my y is getting bigger. So that's now n and then minus 3. And then finally, so this is going to be plus, this is now just x to the 1, and then y, and then this is again getting bigger, so this is n minus 2. And now just so I can fit all of this thing in here in just 2. Okay, and then the last one, obviously now my x is gone. And my last item is going to be y to the n minus 1. And then, of course, my bracket closes down there. So I just kind of ran out of space. So let me shift this over a little bit again. So that's what I'm going to have. Now you'll say, oh my gosh, I have to kind of remember this. You know, is this going to be helpful? It is helpful. You know, if you continue on in mathematics, you're going to find this thing pretty useful, okay, this difference, especially if you're trying to do a lot of proofs, because it's one of the tricks to be able to do, as I mentioned, for example, in calculus. So in here, now, how do I know that this indeed is the result? Now that we have this, all right, let's try to actually prove that this indeed, the right-hand side is indeed equal to this left-hand side, right? So how you would do that is you would simply take, so I'm going to be taking my x, and I'm going to be multiplying by each term here. So I'll multiply by all of these terms, right, all the way through, Okay, and then I'm going to multiply it, for the entire thing right there. So if I do that, what I will have is I'm going to have, so multiplied by the first one, I'm going to get x to the n. So that is great. Okay, so that's one thing that I need. And now I have to multiply it through the rest. Now I'm going to change colors here because what I'm doing is now I'm going to be multiplying through all of these, okay, as I'm going along. Okay, and then of course, I'm multiplying it through the whole thing. So if I would do that, I'm going to get plus, and this is going to be x n minus 1, y to the 1, and then it's going to be x n minus 2, y to the 2, and I will continue this through. So I'm going to just create an entire column, right? So these are all just pluses in here. Okay, so I'm going to be doing pluses. Let me just do that in fast forward fashion, right? I'm just going to be multiplying, and then I'm going to come back and do it with the y. Okay, so I'll be right back. All right, so that's what I have. So I just kind of expanded it out. Okay, so you're noticing, and I just put it up in a column. Now I'm going to now take my y, and I'm going to do the same thing. So with the y, let me just erase all of this junk in here because I highlighted it through. So now I want to be able to take this y, and it is negative, and again I'm going to be multiplying it by every single term inside of that bracket, so all the way through, okay, within here. And if I would do that again, so I'll just swap the colors in here. Okay, so what I'm going to do is, okay, so this multiplied by here, and I'm going to do it on the side here just so that you can see how nicely things start to fall off in here. So notice that I would get this, then I would say minus, I'm going to get x minus 2, this is going to be y squared. Now I'm going to continue this all the way through in fast forward fashion and then be back. So there you have it. And then now the final, okay, so this y multiplied by this, of course, is going to give me, so it's going to give me minus y to the n if I multiply by that. And all of this that I have in here, so all of these pluses, okay, all of these terms, you hopefully can see very clearly that for all of these terms that I have in here, in that boxed in, all of these will cancel, right? This one minus this one, gone. This one minus this one, gone. And so on. So all you're left with is indeed just this and that. And that actually shows you that indeed that is the pattern of difference of the nth degree in here in between these particular items. So, the difference of squares, difference of cubes, and then the general case falls off in that same pattern. And, so I hope that if you run into this and if you watch this video, you found this useful, you can certainly start applying it. And if you were ever wondering or you need a reference for this, you can always rewatch this. All right, thanks for watching. Okay, we'll see you in a future video. Okay, cheers. Happy math studying. Bye, everybody.